topic 4 of Unit 6 about systems is just a review of all the methods that we have learned, substitution, elimination, and graphing. So you'll notice on number 1 that it asks us to solve the same system 3 different ways. So we should get the same answer for each type or each method that we use, but it's just practicing whether or not you understand the process. Okay, so let's just go ahead and jump in. When I look at this system, I'm going to just try to see what would be the easiest method to use first. I notice that there's no variable that's isolated on its own, so I'm thinking substitution may not be the easiest. They're not solved for y equals mx plus b, so I'm not going to go with graphing. I think I'm going to start with elimination. Now, it doesn't really matter. You could start with the hardest method first. You could think that what I just said was a hard method is not a hard method. But I do know that these are already in standard form, and then it'll be a pretty quick process to get them to have same coefficients with opposite signs. So I'm going to take this top equation and just multiply it by 3, because when I do that, I'm going to get 6x plus 3y equals 18, which means that my y's here, when I add them together, a negative 3y and a positive 3y will equal 0. So I get 7x equals 21. I have eliminated the y. So when I divide both sides by 7, x equals 3. So one value down. Now I'm just going to plug this back into one of these equations to get my y value. I'm going to just do the bottom equation. So it says x minus 3y equals 3, but I know now that x is 3. I'm going to subtract the 3 from both sides, divide by negative 3, and y is equal to 0. So that is my solution. That means over here when I graph this, that should be my intersection point. And when I go over here and I do substitution, it should still be x equals 3 and y equals 0. Okay, so let's go ahead and do substitution. I'm just going to rewrite my equations. Okay, so in order for substitution to happen, we need to have a variable that is by itself, a variable that's been isolated. So I'm thinking this x right here should be pretty easy to get by itself. So I'm just going to add that 3y to the other side. So x equals 3 plus 3y. Now I'm able to substitute this in to the other equation where x is. So I've got 2 times 3 plus 3y plus y equals 6. So now I just continue to simplify and solve. And I do get that y is equal to 0, which matches what I got y is equal to over here. Then again, just like before, I need to plug it back in to ensure that I get the same x. So I'll just use that equation right there. X equals 3 plus 3y, but now I know that y is 0. So x equals 3 plus 0, so x has to equal 3. Perfect, okay? Last method is to graph, so I'm going to use slope-intercept form. So for this top equation, I just need to move the 2x over. So y equals negative 2x plus 6. And then for the bottom equation, I have a little bit more work to do. I'm going to first subtract the x. Oops. And then divide by negative 3. Okay. So I've got my 2 equations here. I just need to graph them on the coordinate grid. So I'm going to do the purple one first. So I've got a y-intercept of negative 1 and a slope of positive 1/3. So up 1 over 3, which is where I hit that point. Up 1 over 3. I'm going to go back the other way a little bit. Okay, so there's the first equation. The second one, we have a y-intercept of 6 and a slope of negative 2. So down 2 over 1. And I do hit that point again. Okay, so I do have an intersection right there at 3, 0, which aligns with the solutions that we got on the substitution and elimination parts. So again, this just goes to show that no matter what method you choose, you should get the same solution no matter what. This also goes to show that your teacher cares about the work that you show, because it's in the work that we can see that you understand substitution or elimination or graphing. If all you give is the answer, we don't know what method you have used, and we're not sure that you understand all 3. So make sure that you show your work that proves you get each of the methods. In order to save a little bit of time on this video, I'm going to not work out number 2 completely. I actually have worked it out earlier, right here. So you can just check your answers, or check your work, really. You should get the same answers all the way across, which is x negative 3 and y equals 4. So again, if you want to check, feel free to pause the video to like go through my steps, compare them with yours for substitution, go through my steps, compare them with yours for elimination. And then I am going to work through one part, which is the graphing section. So when you solve these two equations for slope-intercept form, you get one equation that's pretty easy to graph and another equation that's not so easy to graph. So I'm going to work with you to graph y equals negative 1/2 x plus 5/2. Okay, we typically start with our y-intercept, so in this case 5/2. Well, 5/2 really is 2.5, right? 2.5. So I'm going to go ahead, even though we don't really recommend that y'all do this, I'm going to go ahead and put a point on 2.5, or what I think represents 2.5. If my slope is negative 1/2, well, that means either up 1 over 2, or if I wrote it differently, if I wrote it as negative 0.5 over 1, is it still 1/2? Yes, but it's just written a little differently, where now my rise is 1/2 and my run is 1. So if I do it that way, I'm going to rise 1/2 and run 1. Okay? Rise 1/2, run 1, rise 1/2, and run 1. And now I have hit that intersection point that proves that that really is the solution that I have been getting on the other two methods, right? Negative 3, 4. But I wanted to show how you can make that slope and that weird y-intercept kind of work for you by adjusting the slope to be a different rise and a run. It's still a slope of negative 1/2, but it's just looking at it a little bit differently. Also, now that I'm on a perfect point, that slope of negative 1/2 is a little bit easier to work with. I can truly just go up 1 over 2 and make some other points that are easier to see on the graph. Okay? Don't stress over that too much. That's not something that you will come across very often in your math courses, just because that makes it even harder for teachers to grade. But it is something that you might want to have the conceptual understanding of just for future reference. Okay, so let's keep going. Although it looks like we still have a lot of problems, these actually can go pretty quickly depending on how they are set up. So looking at number 3, it says solve using elimination. So I know that I want to add these together, but if I do that right now, nothing's going to eliminate. So I need to do a little bit of work. I need to multiply at least one of these equations to create the same coefficient with opposite signs. Well, I can't turn a 3 into a 7 very easily, and I can't turn a 3 into a 4. So I'm going to need to multiply both equations. So I think about my least common multiples of 3 and 7 or 3 and 4. I'm thinking it's going to be best to turn my y's into 12y's rather than turning the 3x and 7x into 21x. So let's multiply the top equation by 4 and the bottom equation by 3. That's going to create 12x minus 12y equals 4. And then I'm going to get 21x plus 12y equals negative 15. Now when I add, my y's will eliminate. So I've got 33x equals, those y's disappear, negative 15, and 4 is going to give us negative 11. Divide both sides by 33, and x is equal to negative 1/3. Okay? And then again, to get your answer, you're just going to plug it back into one of those problems. I think I'm going to aim for that top one because I'm multiplying a 3 times my x, which means that that fraction won't be quite so scary. So 3 times negative 1/3 is just going to give us negative 1. I'm going to add it to both sides and then divide by negative 3. So y equals negative 2/3. Okay, this is where fractions really have to start becoming your friend so that you can start realizing that, like, if you've got a denominator of 3, multiplying by a whole number 3 is a good thing because really it's going to just kind of cancel those out. They're going to divide to equal 1 and the fraction disappears. Okay, number 4. This one's already set up for me. They're in standard form. I have same coefficients with opposite signs. I'm going to go ahead and get ready to add this. So 2x plus a negative 2x is 0. Negative 3y plus 3y is also 0. 12 plus 8 is 20. So really I have 0 equal to 20. Well, that is a false statement So that means that my answer here is no real solutions. Okay, and if you think about what this means graphically, that means that this is two parallel lines that are never going to meet. They're not going to share a point. Okay, number 5. Again, these are also set up nicely for me. I'm going to go ahead and add. So that's going to be 0, that's going to be 0, and that's going to be 0. So 0 equals 0. Well, that is a true statement. That is the same thing, right? So the answer here, you might want to say all real solutions, which you could, but you also might think about what you learned at the beginning of the unit, where we talked about there's an infinite number of solutions. Okay, it just depends on the question that they're asking. If they say how many solutions, this would be your answer, how many. But if they say what are they, you would say all the real solutions. Okay, and that's because this is really just the same line written twice. So it's the same thing stacked on top of each other, so all the points are going to be shared. Okay, solve using substitution. So this one on number 6 is not set up for us. It looks a little bit more like an elimination problem, but we know we just need to isolate a variable. So I'm going to move that y over. So x equals 8 plus y, and now I can substitute this in for x. So 2 times 8 plus y minus y equals -4. Going to distribute, combine like terms, move that 16 over, and you should get that y equals -20. So then I need to plug it back in. And here's kind of a tricky thing. X minus y equals 8. Well, if I plug in a -20 for my y, remember, a minus minus actually becomes a plus. X plus 20. So I'm going to subtract 20 on both sides, and x equals -12. Okay. Still working on substitution. So you may see this problem and think, okay, I need to isolate my variable, so I'm going to move that 1/4 x over. Y equals -1/4 x plus 10. That's great. I'm going to substitute this in for y. But really, now what you've created is a problem that has all kinds of yucky fractions, because we're going to have to distribute the 1/3 to the 1/4 and the 1/3 to the 10th. What I would do before you even get started for this problem is multiply to get rid of the fractions. So what can I multiply on the top to get rid of the 1/2 and the 3? Well, the 1/3, sorry. Well, I'm going to look at my denominators, 2 and 3, figure out what is the least common multiple. So in this case, it'd be a 6. Same with the bottom one. I've got a 1/4. What would be the least common multiple? Well, we only have the one fraction, so it's just going to be the 4. So now we multiply to get rid of our fractions. So we've got 3x plus 2y equals 30. And we've got x plus 4y equals 40. Same exact equations, just with differing coefficients at this point. What's awesome about this situation is that now we can see it's actually going to be easier for me to just isolate my x here and move that 4y over. When I do that and then want to go to substitute this into x, the problem is much simpler than what I was trying to do before. Okay, so now I've got 3 times 40 minus 4y plus 2y equals 30. I'm going to do 2 steps in one here. I'm going to subtract that 120, which is going to give me a -90. And then I'm going to combine like terms here, and I get -10y. Then we can divide. So y equals 9. Didn't even end up being a fraction. Okay. Now again, when I go to plug this 9 back in, I can use those original equations printed on my page, or I can use these blue equations I created, which I think actually look a little bit better. Okay. So I'm going to plug it into the bottom one, I think. So x plus 4y equals 40. I'm just plug it in where the y is. So x plus 36 equals 40. I can already tell you it's going to be 4. So that problem really wasn't bad once we cleared those fractions out. Okay, last problem in this set is substitution. You'll notice that we have 3 variables here. Do not stress over this whatsoever. You have the skills that you need to solve it, but don't be panicked if you feel like this one problem is making you feel like you don't understand the whole concept. That's not true. This is just a special kind of problem. So looking at my first and my second equations, there's very little that I can do, but my third equation really only has one variable. And if I divide by 3 on both sides, I see that z is equal to -4. I've already found a value in this system. And if that's the case, I can go plug it in to both of these z's, which gives me 3x minus 2y plus -4 equals 1, and 2x minus 3y plus -4 equals -4. So when I look at it this way, now I just move these guys over, and I've got two equations that look very similar to what we've been working with this entire time. So let's rewrite those. 3x minus 2y equals 5, and 2x minus 3y equals 0. Is that right? Add 4, yeah. Okay, so now if they want us to use substitution, we're going to have to isolate a variable and plug it in to the other equation. Honestly, I would say this would be a much better elimination problem, but either way, it's going to take some extra work. So let's just go ahead and isolate maybe my x on the bottom equation. Okay, I'm going to do that by adding the 3y over and dividing by 2. So x equals, oops, that was a 2, 3/2 y. Now I can plug this in to the x on the top equation here, and I get 3 times 3/2 y, oops, minus 2y equals 5. That's going to give me 9/2 y minus 2y equals 5. I'm running out of room here. Let's just make this all a little bit smaller. Okay, so 2y is really like 4/2, right? This 2 I could change. Let me just erase it and put 4/2. And if that's the case, 9/2 minus 4/2 is 5/2 y. To get rid of that, I'm going to multiply by 2/5 on both sides. And y equals 2. One value down. Now I'm going to go plug it back in. I think I almost need a third color here. Plug it back into my equations. I'm just going to focus on these two blue ones I created right here. And I'm going to use the top equation. So 3x minus 2 times that 2 equals 5. Add the 4 over. So x equals 3. So really I had 3 answers here. The z, the y, and the x. Again, do not base your confidence in this topic on that one problem. Okay, things are about to get real easy. It says finding the solution to a system through a table. You're just looking for the point that is the same in each table. This is some sort of equation over here. Y equals something. I don't know what it is. I guess y-intercept's a -1, so it's going to have to be a -1 here. We could find the slope if we wanted to. Looks like maybe it's 2x plus 1 or minus 1. Really doesn't matter. You don't have to do that at all. Instead, just literally look at the problem. What point is the same in both of the tables? 2, 3, 2, 3. There's your answer, 2, 3. Okay, now this one, we're gonna have to do a little bit of work because we don't have complete tables. But they've given us the equation, so we just need to plug in these inputs and figure out what the outputs are. So if I put a 0 there, 0 minus 4 is -4. If I plug in a 1 here, 1 minus 4, -3. Plug in a 2, etc. Same with this second equation. If I plug in a 0, I get 4. Plug in a 1. -3 times 1 is -3 plus 4 is 1. Plug in a 2. You can also just see how that slope over here is starting to apply to the table. Slope's -3. Well, this is going down 3, down 3. So the next number has to be -5 and -8. Now that I have that, I can look and see again, where do I have the same point in both equations, both tables? 2, -2, 2, -2. Okay, almost done. Last problem, or no, second last problem. If the following equations are part of a system of equations, then what is y minus x? Solve using elimination. So this is, again, not a problem where you're going to just be done after finding x and y. You're going to have to use your x and y to answer their real question. So they ask us to use elimination, which is great because they're already in standard form, but I don't have the same coefficient with opposite signs. My x's at least have opposite signs, So maybe I'll just focus on trying to get those to be the same. Well, their least common multiple is going to be 30. So I'm going to multiply the top by 10, bottom by 3. So I've got 30x plus 20y equals negative 90. And then here on the bottom, I've got negative 30x plus 15y equals negative 15. Now I can add them together, and my x's eliminate. Divide both of these by 35. Ooh, positive. And y is going to equal negative 3. Okay, so then I need to plug it back in. I'm going to plug it back into one of my original equations because those numbers are smaller. So just the top one, 3x plus 2 times y, which I now know. Add the 6 over, divide by 3. Okay, so I have my x and y, but again, the question they wanted to know was what is y minus x? Well, now I know that y is negative 3 minus x, which is negative 1. Well, remember, minus and negative, that really just means plus. So really I've got negative 3 plus 1, which is negative 2. That is your real final answer. Okay, last one. This one says, how many solutions would the system below have? How many solutions? So really, you can have infinite solutions, you can have no solutions, or you can have one solution, at least for the purposes of linear equations. So they've already given us y equals 2x minus 9, and they've given us this other equation. Oops. What I want to do here is I want to move this 2x over so that I can see what this looks like in slope-intercept form. So I've got y equals 2x minus 9, and now I've got y equals 2x plus 9. Well, let's picture those graphically. You don't actually have to graph them with perfection, just kind of visualize. 2x plus 9, well, there's a 9, let's pretend. 2x is a positive slope. We'll say it looks like that. The other equation, 2x minus 9. Minus 9 would be somewhere down here. Slope is 2 again, which means it should have the exact same steepness as the one above it. Okay, well, I notice same slope means that these are going to be parallel. Well, how many solutions are they going to have if they are parallel? They're going to have no solutions. Okay, just keep in mind, if it was the same line, they would have infinite solutions. If it was two completely different lines, they'd have one solution. And this is a different question than what are the solutions. How many is a different type of question than what are they? Okay, it's like saying, how many pieces of candy do you want? And you say Reese's. And I say, no, how many do you want? And you say, I want Reese's. It's a different kind of question. You have to make sure your answer matches the question. Okay, so you've got a practice that really, again, you can tell is just helping you work through the different methods and make sure you understand all three. Please make sure you reach out to your teacher if you have any questions about any of the different methods, because you will need to be able to understand how to do all three fluently. Alrighty, good luck.